Premature incandescent lamp failures can stem from a variety of factors. Addressing these issues requires a systematic approach to identify the root cause and implement effective solutions. Let's explore some of the potential culprits and how to troubleshoot them. Firstly, consider the quality of the lamps themselves. Verify the lamp manufacturer and ensure their quality standards are reputable. It may be beneficial to consider using higher quality lamps specifically designed for commercial applications, as they often have more robust filaments and construction to withstand demanding environments. Secondly, voltage spikes are a common cause of premature lamp failure. To investigate this, install a recording power meter to monitor voltage fluctuations over time. This will help you determine if voltage spikes or transients are exceeding the lamp's rated voltage. Even brief, high voltage spikes can significantly shorten lamp life. Thirdly, incorrect installation practices can also contribute to the problem. Ensure that the lamps are firmly seated in their sockets and making good contact. Loose connections can cause arcing and heat buildup, leading to premature failure. Also, check that the recessed cans are properly ventilated and not trapping heat around the lamps. Overheating can significantly reduce lamp life. Fourthly, power quality issues beyond simple voltage spikes can also be a factor. Contact the utility company to investigate the overall stability of the power supply. Ask them to check for harmonic distortion or other power quality issues that can stress the lamps. Harmonic distortion, in particular, can cause increased current flow and overheating. Fifthly, electrical faults within the building's wiring can also lead to lamp failures. Carefully check for loose connections, damaged wiring, or other electrical faults in the circuit. Use a multimeter to test and ensure proper grounding. Poor grounding can create voltage imbalances and increase the risk of electrical surges. Sixthly, ambient temperature plays a crucial role in lamp life. Measure the ambient temperature around the lamps, especially within the recessed cans. High temperatures can significantly shorten lamp life. Ensure that the recessed cans are clear of any obstructions that may trap heat. Proper ventilation is essential for dissipating heat and extending lamp life. Seventhly, vibration can also contribute to premature filament failure. Check for excessive vibration from nearby equipment such as HVAC systems or even from foot traffic. Vibration can weaken the filament and cause it to break prematurely. Consider using vibration dampening mounts or relocating the lamps if vibration is a significant issue. Eighthly, if fluorescent fixtures are installed nearby, their electromagnetic interference, or ME, can affect the lamp life of the incandescent lamps. EMI can disrupt the electrical current flowing through the filament, leading to premature failure. Try relocating the lamps or installing EMI filters to mitigate this issue. Ninthly, exposure to corrosive chemicals or fumes can also damage the lamps and shorten their lifespan. Check for any potential sources of chemical exposure in the area. Provide adequate ventilation and keep the lamps away from such substances. Chemical exposure can weaken the glass envelope and corrode the filament. When troubleshooting these issues, there are several practical steps you can take. Firstly, replace the lamps with high-quality replacements from a reputable manufacturer. This will eliminate the possibility of faulty lamps being the primary cause. Secondly, install a recording power meter to monitor voltage and power quality over an extended period. This will provide valuable data for identifying voltage spikes, transients, and harmonic distortion. Thirdly, carefully verify the electrical installation and grounding. Ensure that all connections are tight and that the grounding system is properly functioning. Fourthly, check for any ambient temperature or vibration issues. Address any factors that may be contributing to overheating or excessive vibration. Fifthly, eliminate potential sources of EMI. Relocate lamps away from fluorescent fixtures or install EMI filters. Sixthly, contact the utility company for further investigation of power supply stability. They may be able to identify and address any power quality issues that are affecting the lamps. In summary, troubleshooting premature incandescent lamp failures requires a comprehensive approach. By systematically investigating potential causes such as low-quality lamps, voltage spikes, incorrect installation, power quality issues, electrical faults, ambient temperature, vibration, EMI, and chemical exposure, you can identify the root cause of the problem and implement effective solutions. Implementing these steps will extend lamp life and reduce maintenance costs. It is crucial to remember that even small deviations from optimal operating conditions can significantly impact the lifespan of incandescent lamps. Therefore, meticulous attention to detail during installation, maintenance, and troubleshooting is essential. In addition to the factors already mentioned, there are a few other considerations that can contribute to premature incandescent lamp failure. One often overlooked factor is the frequency of switching. Incandescent lamps are particularly susceptible to damage from frequent on-off cycles. Each time the lamp is switched on, the filament experiences a thermal shock as it rapidly heats up. This thermal stress can weaken the filament over time, leading to premature failure. If the lamps are being switched on and off frequently, consider using a different type of lighting, such as LED, which is much more resistant to switching cycles. Another consideration is the type of dimmer being used, if any. Not all dimmers are compatible with all types of incandescent lamps. Using an incompatible dimmer can cause flickering, buzzing, and premature lamp failure. Ensure that the dimmer is specifically designed for use with the type of incandescent lamp being used. Additionally, consider the orientation of the lamp. Some incandescent lamps are designed to be operated in a specific orientation, such as base up or base down. Operating the lamp in the wrong orientation can cause uneven heating of the filament and shorten its lifespan. Check the lamp manufacturer's specifications to ensure that the lamp is being operated in the correct orientation. Furthermore, the design of the fixture itself can play a role in lamp life. Fixtures that trap heat or restrict airflow can cause the lamp to overheat, even if the ambient temperature around the fixture is within acceptable limits. Ensure that the fixture is properly ventilated and that it is not obstructing airflow around the lamp. In some cases, the problem may not be with the lamps themselves, but with the electrical circuit supplying power to the lamps. A loose neutral connection can cause voltage fluctuations and imbalances that can damage incandescent lamps. Have a qualified electrician inspect the electrical circuit to ensure that all connections are tight and that the neutral connection is properly grounded. Another potential issue is the presence of transients on the electrical circuit. Transients are brief, high-voltage surges that can damage electronic equipment, including incandescent lamps. Transients can be caused by a variety of factors, such as lightning strikes, switching of heavy equipment, or problems with the utility grid. Installing surge protection devices can help to protect the lamps from damage caused by transients. Finally, consider the age of the electrical wiring in the building. Over time, electrical wiring can deteriorate, leading to increased resistance and voltage drop. This can cause the lamps to operate at a lower voltage than they are designed for, which can shorten their lifespan. If the electrical wiring is old or damaged, consider having it replaced by a qualified electrician. By carefully considering all of these factors, you can effectively troubleshoot premature incandescent lamp failures and implement solutions to extend lamp life and reduce maintenance costs. Remember to prioritize safety when working with electrical equipment. Always disconnect power before performing any maintenance or troubleshooting. If you are not comfortable working with electrical equipment, contact a qualified electrician. It is also important to keep accurate records of lamp replacements and any troubleshooting steps that you have taken. This will help you to identify patterns and trends that can help you to prevent future lamp failures. For example, if you consistently find that lamps in a particular fixture are failing prematurely, it may indicate a problem with the fixture itself or with the electrical circuit supplying power to the fixture. By keeping accurate records, you can identify these problems and take steps to address them before they lead to further lamp failures. In addition to the troubleshooting steps outlined above, there are also some preventative measures that you can take to extend the life of incandescent lamps. Firstly, use high-quality lamps from reputable manufacturers. These lamps are typically made with more durable materials and are designed to withstand the rigors of commercial use. Secondly, avoid frequent switching of the lamps. If possible, use a timer or occupancy sensor to automatically turn the lamps on and off. Thirdly, ensure that the fixtures are properly ventilated and that they are not trapping heat around the lamps. Fourthly, install surge protection devices to protect the lamps from damage caused by transients. Fifthly, have the electrical wiring in the building inspected regularly by a qualified electrician. By taking these preventative measures, you can significantly extend the life of incandescent lamps and reduce maintenance costs.